Chapter 4 is on systems of linear equations. So we've already seen that the solutions to an equation of the form ax plus bx plus c, any linear equation in two variables, linear meaning it has no exponents, can be graphed as a straight line. Okay, so the solutions would be any point on that straight line. If I graph two equations, two such equations make a system of linear equations, or you can just call it a system for short. And a solution to a system of linear equations in two variables is an ordered pair or set of ordered pairs that satisfies both equations. In example 1, I want to determine whether the ordered pair 2, -3 is a solution to the system. So we need to plug this ordered pair in to both equations and see if it does satisfy both. Let's look at the first line first. 2x, x is 2, plus 3 times y, which is -3. Let's see, is that equal to -5? 2 times 2 is 4. 3 times -3 is, 3 times -3 is -9. So is that equal to -5? And so far so good. This is -5 is equal to -5. Let's look at the other ordered pair. It's no good if it's a solution to one but not the other, so I must check both. Let's try the other one. 7 times 2 minus 3 times -3. And I want to know this time, is it equal to 23? 7 times 2 is 14. Plus 9, is that equal to 23? 14 plus 9 is 23. So I have a true statement here again. So my overall answer when I'm determining whether the ordered pair is a solution to the system is going to be yeah, yes it is. Because I got a true statement out of both equations. Okay. Now let's find all of the ordered pairs that satisfy both the equations in this system. Okay. Now I'm going to do that by graphing the two equations on the same grid. So remember that when I graph the equations, I'm going to first identify the y-intercept, then the slope. In the first equation, the y-intercept is -1. So I'm going to plot that. Then the slope is 2. So 2 is the fraction 2 over 1. So I'm going to go up 2 over 1. And I'm going to keep doing that, up 2 over 1, up 2 over 1, until I can get all the ordered pairs on this grid. Vice versa, I'm going to go down 2 and back 1. Two negatives also make a positive. So down 2, back 1, down 2, back 1. It's going to allow me to connect these with my ruler very quickly. So when I connect them, this line will look like this. Okay. My line's so thick you can't see my ordered pairs anymore, but they helped me line this up very quickly. Okay, let's graph the next one. So the next one has a y-intercept of 5 and the slope of -1. -1 is 1 over 1, -1 over 1. So down 1 over 1, 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 etc., etc. And in the reverse, I would go up 1 and back 1. Okay, I can have that negative on either side. So up 1 and back 1 is also a -1. So let me connect those. My line's definitely going to be so thick I'm not going to be able to see much of anything. Let me see if I can get a different line, a little bit thinner. Let's use this one. There we go. Okay, now what we're looking at here is the solution. And the solution should be the place where the two lines intersect. So these two lines intersect at the ordered pair 2, 3. I'm writing that in the wrong spot. The solution is the point where the two lines intersect. And as we've already noticed, that solution in this system is 2, 3. That's the ordered pair where these two lines intersect. There's only one solution, notice, only one place where these two lines intersect. Okay, we're going to do a similar thing in this next exercise. We are going to solve this by graphing. So I need to first graph the first line, then graph the second line. Before I can graph the first line, I need to rewrite it so that I can put it in slope-intercept form. or I need to solve for y. So let's subtract x from both sides. Y is equal to negative x plus 1. This gives us a slope of negative 1 and a b value of positive 1. B value of positive 1, plot it. Then my slope of negative 1 is negative 1 over 1. So again, down 1 over 1, down 1 over 1, down 1 over 1 to graph my ordered pairs. And vice versa, we can go back 1, up 1, back 1 and up 1, up 1 and back 1 to graph all the rest of the ordered pairs. And we're going to connect those. So let me grab a line tool and connect. Alright. Graph the first line. Now we need to graph the next one. So that line also is not yet in the right form. Let's put it in the right form. So right now it's written as y minus x equals 3. I want to get y by itself. So y minus x, we're going to add x to get rid of that. So y equals x plus 3. Slope in this one is 1. Y-intercept is 3. So I'm going to start at 3. On the y-axis, 1 is 1 over 1. So we'll go up 1 over 1, up 1 over 1, up 1 over 1, graphing all of those ordered pairs. And the same in the reverse. 2 negatives make a positive, so I can go down 1, back 1, down 1, back 1, down 1, back 1, and so on. Then I'm going to connect all of these ordered pairs. Okay. Now I can see that the solution is the place where the two lines intersect. They intersect right here at the ordered pair that has x value negative 1 and y value 2. So the solution is negative 1, 2. And again, there's only one solution, only one place where those two lines intersect. So I list the ordered pair as the solution, the answer to that system. Let's look at the next one. Okay. Alright, so the summary of directions here lets us review that when we want to solve a system, I'm going to graph the first equation, graph the second equation on the same axes, look at where they intersect, determine the coordinates of that ordered pair, and then I may want to check that solution in both of the equations. Okay, so let's look at the next one. Okay, first thing I need to do is solve for y in this first equation. So this equation would be, right now it's 2x minus 5y equals 15. And so I'm going to subtract 2x from both sides. That would give me negative 5y. That was a subtraction of 2x, so equals negative 2x plus 15. And then divide everything by negative 5. So that gives me y equals negative 2 divided by negative 5 is going to be positive 2/5 x. 15 divided by negative 5 is going to be negative 3. So let's start graphing this. To graph this, I want to know the b value, which is negative 3. I'm going to start there. And I need to know the slope, and the slope is a positive 2/5. So from that negative 3, we're going to go up 2 and over 5, up 2 and over 5. Vice versa, we could say that's the same thing as a negative 2, negative 5. 2 negatives make a positive. I'm going to go down 2 and over 5, and down 2 and over 5. Okay, so let's connect these. There we go. Got our first line graphed. Let's go back up and look at the next line. Okay, the other line is already written in slope-intercept form. I don't need to solve for y. Y is already solved for. So we can start by just saying the m is negative 3/5. And the b is 2 for this line right here. So I'm going to start by plotting the y-intercept value, the b value at 2. Then since the slope is negative 3/5, we'll go down 3 over 5. Down 3 over 5, and in reverse, to graph this line, we'll go up 3 back 5, up 3, back 5. Now let's go ahead and connect these points to finish graphing that line. Okay, and as you can see, when I was dotting those points in, the intersection occurred right here. The solution, that ordered pair of the intersection, is going to have x value 5 and y value -1. So it's the ordered pair 5, -1 is our solution. Let's look at the next one. Okay, let's go ahead and graph each of these. These two equations are already in slope-intercept form, so I'm just going to start by graphing them. My b value is 2 in the first one, and my slope is 1/4. So I'm going to start with a b value of 2, and the slope of 1/4 means up 1 over 4, up 1 over 4, or down 1, back 4, down 1, back 4. And let's connect these. Okay. And then the second line has a b value of -3 and a slope of 1/4. Okay, so -3. And the slope was 1/4, so up 1 over 4, up 1 over 4, or down 1, back 4, down 1, back 4. So as you probably already noticed, since they had the same slope, these two lines are parallel. And since they're parallel, there will be no solution. They're never going to intersect. Remember, the solution is asking the question, where do these two lines intersect? These two lines will never intersect, so there's no solution. That's what I need to write. No solution. Okay, that's the answer. And when this happens, the system is called independent and inconsistent, and the type, I guess, would just be parallel. The inconsistent part of this, independent means that the two lines are distinct and different, and inconsistent means that there is no solution. And the reason behind that is because the two lines are parallel. Okay, so these are just a couple of the words you might see associated with a problem like this. It's a set of two independent lines, but it's inconsistent, no solution, and because they're parallel. The formal answer to this would be that this system has no solution. All right, let's look at the next one. Okay, let's solve this system. I'm going to go ahead and graph the first line. That line is already in the right form. I know the b value is -5, the m value is 2. So when I graph this, the b value is -5, the m value is 2, which is 2 over 1. So I'm going to go up 2 and over 1 from this point. Up 2 and over 1, up 2 and over 1, and so on. I'm going to be able to connect these into a nice line. Or down 2 and back 1, down 2 and back 1 for the two negatives. Okay, let's draw these. Okay, there's a quick sketch. And then let's go ahead and look at the next line. Okay, I need to solve for y on the next line, so I'm going to subtract 4x from both sides. That gives me -2y equals -4x plus 10. Then we're going to go ahead and divide by -2 to get y by itself. So y equals -4 divided by -2 is -2. Oops, divided by -2 is +2. X, 10 divided by -2 is -5. Notice that this equation is the same as this one. That means that if I graph it, it's going to start at 5, go up 2 over 2, up 2 over 2, up 2 over 2, and its graph is going to look just like this one. So when I finish graphing it, I'm going to see only that one line, because they're both actually the same line. Okay? Since they're both the same line, this system is called dependent. And it has infinitely many solutions. Infinitely many solutions, since any ordered pair on that line is going to make that system true.